October 22, 1945, 1432 Eastern Standard Time. P.O. Box 1142, Fort Hunt, Virginia. Inside a windowless, smoke-filled interrogation room, the clatter of a 16mm Bell & Howell film projector was the only sound. General Major der Pioniere, Klaus von Lettow, a veteran of the Eastern Front with over 25 years of service, watched the flickering black-and-white images. An American major from the Center of Military History observed as footage from training film TF-5-1158 showed a U.S. Army engineer company assembling a massive bridge in under 6 hours. Von Lettow's stoic composure, forged in the fires of Stalingrad, finally cracked. It wasn't just a bridge, it was a doctrine, an industrial miracle he'd dismissed as impossible propaganda. The strategic problem facing the Allies in the summer of 1944 was one of simple, brutal physics: water. As General George S. Patton's U.S. Third Army tore across France at a blistering 40 miles a day, the retreating German Wehrmacht, under the ruthlessly efficient command of General Feldmarschall Gunther von Kluge, executed a perfect scorched earth campaign. Every single bridge over the Seine, the Marne, and the Moselle was expertly demolished, leaving behind nothing but shattered concrete and twisted steel. For the more than 15,000 vehicles of Patton's armored divisions, a 100-foot gap was as impassable as an ocean. German doctrine, honed by the prestigious organization TUT, dictated that a replacement bridge of that size was a matter of weeks, involving heavy cranes, concrete foundations, and thousands of man-hours. The German High Command was certain this strategy would bleed the Allied blitzkrieg dry, forcing a logistical halt that would allow them to regroup and fortify a new defensive line. They just didn't know the Allies weren't going to play by their rules. The answer to this continental-scale problem didn't come from a decorated general, but from a quiet, unassuming British civil servant named Donald Coleman Bailey. A 1923 graduate in engineering from the University of Sheffield, Bailey was a meticulous designer who preferred a tweed jacket to a uniform and always smelled faintly of pipe tobacco and damp wool. On November 5, 1940, during a tedious meeting at the experimental bridging establishment in Christchurch, he sketched an idea on the back of an envelope. It was a simple, cross-braced steel frame, 10 feet long and weighing 570 pounds. The genius was in the connection. Simple steel pins, not bolts or rivets. Under the supervision of Lieutenant Colonel G.H. Hines, Bailey refined his concept, driven by a singular obsession: create a bridge that could be built by hand, transported in a standard 3-ton truck, and assembled faster than the enemy could possibly believe. The theory was one thing. Reality was a 25-ton Churchill tank threatening to plunge into the Sandpit Marshes. On May 1, 1941, Bailey and a team of Royal Engineers watched nervously as the prototype, an 80-foot single span, took the full weight of the beast. The air was thick, with the smell of marsh grass and hot metal, as the tank, driven by Sergeant Major Alistair Finch, rumbled onto the structure. For a terrifying second, the bridge groaned, a deep, metallic protest against the immense load, before settling. It held. The engineers erupted in cheers, their shouts echoing across the water. They had done it. But a clever invention in England wasn't going to win a war in France. That leap required an American with a vision of industrial warfare on a scale the world had never seen. Lieutenant General Eugene Raybould, a 1909 West Point graduate and the U.S. Army's chief of engineers, saw Bailey's design not as a bridge, but as a weapon of logistical supremacy. From his headquarters at Fort Belvoir, Virginia, Raybould initiated the largest military engineering procurement in history, commissioning over 700,000 tons of components from 624 different American corporations, from the American Hoist and Derrick Company in Ohio to smaller shops in Pennsylvania. He didn't just order parts, he created a doctrine, a standardized, repeatable system that could turn 40 engineers into a bridge-building machine. Before I tell you how General Raybould and his engineers used this system to build a bridge across the Rhine in just 10 days, comment below where you're watching from and subscribe to the channel. Believe me, you won't want to miss the story of how this industrial secret blinded the entire German High Command. By August 15, 1944, the German strategy was one of elegant, brutal simplicity. Under the direct orders of General Feldmarschall Günther von Kluge, German pioneer battalions worked with terrifying efficiency. It took them less than 48 hours to wire a 150-foot stone bridge with over 200 kilograms of hexenite, rigging the charges to shatter the central piers beyond repair. The sharp crack of the explosives echoing through the French river valleys was, to General Major der Pionier Klaus von Lettow, the sound of a guaranteed operational pause for the enemy. They didn't just blow the bridges, they salted the earth. Across the front, the problem for men like General George S. Patton was a beast of insatiable appetite. By July 31, 1944, his Third Army was a roaring tide of over 15,000 vehicles, from jeeps to M4 Sherman tanks, each powered by a Continental R975 C4 9-cylinder radial engine that helped consume a staggering 400,000 gallons of gasoline every single day. The constant, deafening rumble of engines was the sound of victory, but the metallic tang of diesel exhaust was the constant smell of impending logistical failure. Captain Samuel Grossman of the 299th Engineer Combat Battalion knew that for the 12th Armored Division, a single destroyed bridge wasn't a delay. It was a potential death sentence, starving the beast in its tracks. This German doctrine of methodical destruction was the life's work of men like General Major Klaus von Lettow, a proud 1922 graduate of the Technische Universität Berlin. He was the epitome of the German engineering elite, a man who saw war as a series of complex structural problems to be solved with absolute precision. He'd spent the brutal winter of 1942 near Smolensk, overseeing the construction of a 500-ton railway bridge designed to carry the colossal Krupp K5 gun, a project that took 4 months, thousands of slave laborers, and immense quantities of reinforced concrete. The biting cold, the taste of ersatz coffee, and the solid permanent feel of his creations defined his world. The idea of a temporary, rapidly built structure was anathema to him, a sign of weakness, a concept he and his superiors, including the influential Albert Speer, simply could not respect. But back in Washington, an entirely different philosophy was taking hold. On October 1, 1942, Lieutenant General Eugene Raybould, a man who saw America's industrial might as its greatest weapon, signed off on a procurement order that would have staggered a lesser mind. He commissioned 700,000 tons of steel components from 624 different American corporations, all to be manufactured to a precise specification of A36 steel, with a minimum yield strength of 36,000 psi. In his office, the frantic clatter of teletype machines was the sound of a new kind of war being waged, one that Secretary of War Henry L. Stimson fully endorsed. This industrial theory had to be proven in the mud and sweat of training. In the spring of 1943, at Fort Belvoir, Virginia, Captain Samuel Grossman's 40-man platoon from the 299th Engineer Combat Battalion endured 18-hour training days under the stern gaze of First Sergeant Michael "Iron Mike" O'Connell. The curriculum was brutal repetition: lift the 570-pound Bailey panel, slide it into place, drive the pin. The rhythmic clang of sledgehammers on steel pins became their anthem. The splintery, rough texture of the wet wooden road planks slick with morning dew and the constant strain in their backs was a daily reminder of the physical cost of this new doctrine. Lieutenant General Eugene Raybould, a 1909 West Point graduate, was the quiet architect of this revolution. At 58 years old in 1942, he was a stern, imposing figure in a perfectly pressed uniform who rarely raised his voice. He had a habit of tapping a silver pen against a heavy crystal ashtray while listening, his mind methodically processing logistics on a continental scale. In a humid meeting on June 20, 1942, with General Brehon B. Somerville, head of Army Service Forces, Raybould laid out a vision that went far beyond a single piece of hardware. He saw the standardized GMCCCKW 2.5-ton 6x6 truck not just as transport, but as a conveyor belt delivering interchangeable parts from over 600 factories directly to the battlefield. He wasn't just building bridges. With a budget exceeding $10 billion, he was weaponizing the American assembly line. Meanwhile, German intelligence, the Abwehr was strategically blind. Admiral Wilhelm Canaris's organization was obsessed with Allied tank counts and bomber production. When reconnaissance reports from Focke-Wulf FW-189 aircraft mentioned new, rapidly built bridges, they were filed away. On August 20, 1944, NIM General Oberst Alfred Jodl reviewed over 200 such reports at the Wolfschanze. The idea that a significant bridge could be built in under 10 hours was dismissed with a dismissive wave of his hand in the smoke-filled room. It was simply unbelievable, and therefore, it was treated as propaganda, a lie not worth investigating. The whole concept was born from a moment of quiet, genius worlds away from the battlefield. On November 5, 1940, Sir Donald Coleman Bailey, a 39-year-old civil servant who smelled faintly of pipe tobacco and damp tweed, was doodling on an envelope. A 1923 University of Sheffield engineering graduate, he wasn't a soldier but a problem solver, under the patient guidance of Lieutenant Colonel G.H. Hines at the experimental bridging establishment. Bailey refined his initial sketch through over 200 blueprint revisions. The true innovation wasn't the steel panel itself, but the simple, elegant, 18-pound steel pin connection that required no complex machinery to assemble. This new kind of war demanded a new kind of officer. Captain Samuel Grossman, who graduated summa cum laude from MIT in 1938, was that man. He had enlisted on December 8, 1941, trading the quiet, book-dusted office of his father, Professor Jacob Grossman, for the chaos of war. He wasn't a natural warrior. He was an academic with a Kweifel and Esser slide rule in his breast pocket and a piece of tape holding his glasses together. He had a nervous habit of pushing them up his nose before giving an order, his mind a constant whirl of load calculations and stress vectors. The constant feeling of grit under his fingernails and the unending tension in his shoulders was the price of translating his theoretical genius, which earned him a 148 on his Army classification test, into battlefield reality for 40 men who depended on him. For the German command, the equation was simple. By late August 1944, NAM's General Feldmarschall Erwin Rommel's strategy, continued by his successors like von Rundstedt, had resulted in over 50 destroyed bridges across the Seine alone, creating a formidable defensive line nearly 300 miles long. The approaches were often seeded with Tellermine 43 anti-tank mines. The hollow silence hanging over a dynamited river valley, a silence the Germans believed would last for weeks, was the cornerstone of their entire defensive plan for France. They were certain it would hold. The existing Allied equipment only reinforced this German confidence. The standard U.S. Army M2 Treadway Bridge was a cumbersome pontoon system, a series of floating platforms highly vulnerable to fast river currents, and a single, well-placed artillery shell. As Major General Hugh J. Gaffey's 4th Armored Division approached the Moselle River on September 5, 1944, the engineers of Colonel W.A. Carter's 1,303rd Engineer Regiment felt the pervasive damp chill rising from the water at dawn. It was the smell of wet earth and fear, the dread of attempting a crossing with technology they knew was fatally flawed. This technological gap was rooted in a deep philosophical divide. The German engineering ethos, perfected by Fritz Todt and his organization Todt, was one of monumental permanence. By 1944, the organization employed over 1.4 million laborers, building the Atlantic Wall with 17 million cubic meters of concrete. Their projects, overseen by men like Dr. Carl Sauer of the Armaments Ministry after Tott's death in 1942, used massive concrete caissons and heavy steel I-beams, requiring dedicated railway lines and 100-ton cranes. The overwhelming smell of wet concrete and the deafening roar of pile drivers were the sensory hallmarks of their craft. To them, a bridge was a testament to the Reich, built to last 1,000 years. A disposable, hand-built alternative was not just impractical, it was an ideological impossibility. The consequences of a halt were dire. The entire Allied war machine, with 28 divisions in France by August 25, 1944, was tethered to a fragile 2,000-mile supply line stretching back to the beaches at Cherbourg. The famous Red Ball Express truck convoy, praised by General Omar Bradley and General Dwight D. Eisenhower, could barely keep up on intact roads. A week-long delay at a river meant thousands of vehicles running out of fuel, their armor useless, sitting vulnerable to German counterattack. It was the gnawing anxiety of a fuel gauge hitting empty, the cold dread of total immobility. The sheer scale of the German demolition campaign was staggering. Between August 1st and August 15th, 1944, as Major General Troy H. Middleton's 8th Corps advanced, German pioneers destroyed over 2,500 bridges and culverts in the Brittany region alone. For Allied commanders like Brigadier General Truman C. Thorson, the frustrating sight of the opposite riverbank, so close yet utterly unreachable, became a defining image of the campaign. The demoralizing echo of enemy demolition charges, heard day after day, signaled another obstacle, another potential quagmire that existing doctrine had no answer for. In the stale, filtered air of the Wolfschanze headquarters on September 1, 1944, that confidence was absolute. Unrolling a map across a heavy oak table, General Oberst Alfred Jodl used a polished ruler to show Adolf Hitler how the Allied advance would bleed out against the natural barrier of the Moselle River. The OKW's official strategic assessment predicted a complete halt for a minimum of 3 weeks. After all, their own Pioneer Bataillon Doctrine, a manual bound in decades of experience, stated that a 120-foot bridge would take 250 men at least 14 days to complete. Physics, time, and the rivers of France were their allies. They were certain. They had no idea a new kind of physics was about to be unleashed. It all began on November 5, 1940, not with a bang, but with a scribble. Inside a drab meeting room at the experimental bridging establishment in Christchurch, Sir Donald Coleman Bailey, a quiet civil servant from the War Office, tuned out the droning voices. He smelled the stale pipe tobacco in his tweed jacket as he sketched on the back of a GPO envelope. It was a simple, cross-braced frame, 10 feet long, with a revolutionary idea in the corners. A simple hole for a pin, not a bolt. This simple sketch, from a 1923 Sheffield engineering graduate, would change everything. From that initial sketch, the concept moved into the secrecy of the EBE's camouflaged Nissen huts, hidden among the coastal pines of Hampshire. Under the watchful eye of Lieutenant Colonel G. H. Hines, Donald Bailey worked tirelessly, translating his idea into over 200 blueprint revisions between November 1940 and April 1941. The real genius wasn't just the 570-pound steel panel, but the 18-pound steel pin that connected them, a simple, robust solution that eliminated the need for complex tools or skilled welders on the battlefield. The entire system was designed for 6-man teams, with every component, from the transoms to the bracing, weighing no more than 600 pounds. The air in the workshops was thick, with a sharp scent of cutting oil, and the constant, high-pitched whine of metal lathes as they perfected a weapon no one yet understood. The theory was finally put to the test on a damp morning, May 1, 1941. An 80-foot single span, its fresh paint gleaming, stretched nervously across the Stanpit marshes. The air was heavy, with the smell of wet earth and diesel, as a 25-ton Churchill tank, commanded by Sergeant Major Alistair Finch of the Royal Engineers, rumbled towards it. For a heart-stopping moment as the massive vehicle crawled onto the structure, the bridge let out a deep, metallic groan. Donald Bailey held his breath. Then, silence. It held. The war had a new weapon, but a British invention needed American industrial muscle to become a war winner. That muscle had a name: Lieutenant General Eugene Raybould. A stern 1909 West Point graduate, Raybould was the U.S. Army's Chief of Engineers, a man who saw logistics as the ultimate expression of power. He was a physically imposing figure who rarely smiled, with a habit of tapping a silver Waterman pen against a heavy crystal ashtray as he listened. In a pivotal meeting on June 20, 1942, with General Brehon B. Somerville, Raybould didn't just propose adopting the British design. He outlined a vision for its mass production by over 600 U.S. corporations. He saw the Bailey Bridge not as a piece of equipment, but as a doctrine, a system of interchangeable parts delivered by a conveyor belt of GMC trucks that would make the German concept of a river defense obsolete. He was going to weaponize the American factory. By October 1, 1942, Raybould's vision was thundering into reality. From his office at the War Department, he authorized the procurement of over 700,000 tons of components, a logistical undertaking of immense scale. Companies like the American Hoist and Derrick Company in Ohio and the Commercial Shearing and Stamping Company in Pennsylvania were contracted to produce individual, unlabeled parts. Every panel was manufactured to a precise specification using A36 steel with a minimum yield strength of 36,000 psi and a tolerance of 1/32 of an inch. The security protocol, devised by Colonel James B. Newman of Raybould's staff, was absolute need to know. The 624 factories only knew they were making steel frames or pins. They had no idea their combined output was creating a weapon that could bridge the Rhine. This industrial compartmentalization was the core of the project's secrecy, codenamed Operation Trestle. All shipping manifests, overseen by the Army Service Forces, were classified, listing components only by cryptic part numbers like Item WBP1 for a panel or Item WBP2 for a pin. A spy infiltrating a factory in Youngstown, Ohio, would see nothing but the mass production of what looked like generic scaffolding. Lieutenant General Eugene Raybould and Secretary of War Henry L. Stimson had designed a system where the secret wasn't a blueprint in a safe. It was a puzzle scattered across 48 states. The hardware was useless without the human software to run it. Starting in September 1942, Fort Belvoir, Virginia, became the crucible where this new doctrine was forged. On the muddy banks of the Potomac River, the U.S. Army Engineer Board, under the direction of Brigadier General John W.N. Schultz, conducted over 200 brutal stress and assembly tests. They pushed the components to their limits, applying loads up to a 1.5 safety factor on triple-triple configurations, designed to hold a 70-ton M26 Pershing tank. The results were codified into Field Manual FM 5-270, a step-by-step Bible for every engineer company. The humid Virginia air was filled with the rhythmic clang of sledgehammers on steel, the shouts of NCOs timing platoons with stopwatches, and the constant smell of sweat and damp canvas as thousands of men, including Captain Samuel Grossman's company, were drilled until the assembly of a 120-foot bridge became muscle memory. For the men of the 299th Engineer Combat Battalion, the theory became a harsh physical reality. A 40-man platoon under a leader like Captain Samuel Grossman, a 1938 MIT graduate, learned the brutal calculus of the system. 6 men to a 570-pound panel, 2 men to an 18-pound pin. They mastered the assembly of the lightweight launching nose that allowed them to cantilever the entire structure across a 100-foot gap without a single man getting his feet wet. The rough, splintery texture of the wooden road planks and the cold, unyielding steel of the panels became their world. They learned to build a double single for an M4 Sherman tank in under 8 hours, their hands raw, their backs aching, turning raw steel into a highway for an army. This wasn't a cheap endeavor. The initial congressional appropriation for Operation Trestle in fiscal year 1942 alone was over $100 million, a figure personally approved by Secretary of War Henry L. Stimson on August 15, 1942. This colossal investment, nearly 2% of the entire War Department budget for engineering that year, was a closely guarded secret. It demonstrated that men like General George C. Marshall and Lieutenant General Eugene Raybould understood that victory wouldn't just be won by tanks and planes, but by an overwhelming logistical supremacy built on a foundation of American steel and ingenuity. Ultimately, the true secret weapon wasn't the bridge itself, but the integrated system that delivered it. Lieutenant General Eugene Raybould and his Chief of Staff, Major General Cecil R. Moore, perfected a doctrine where logistics became offensive. Every single GMCCCKW 2.5-ton, 6x6 truck in the Engineer Corps was a standardized mobile toolkit. A company commander like Captain Samuel Grossman could radio in a request for a 120-foot DS bridge, and within 2 hours, a convoy of exactly 12 trucks, each preloaded from a specific manifest at a depot 50 miles behind the lines, would be dispatched. It was a seamless, invisible conveyor belt stretching from the factory floors of Pittsburgh to the riverbanks of France. The constant, low hum of those thousands of truck engines was the true, secret sound of this revolutionary weapon, a sound the German High Command would never comprehend until it was far too late. On September 2, 1944, at 14:15 hours, Oberleutnant Erich Richter of Aufklärungsgruppe 11 banked his Focke-Wulf FW-189 reconnaissance plane over the Meuse River. The air at 4,000 feet smelled faintly of exhaust and damp earth. His morning sortie at 7 o'clock had confirmed the pioneers of the 512th Grenadier Division had perfectly demolished Bridge 34, leaving a 140-foot chasm. Now, just 7 hours later, a new steel bridge was in place, with a column of at least 50 M4 Sherman tanks already crossing. He radioed his report to his controller, Hauptmann Franz Bauer, who simply couldn't believe it. Richter's logbook entry, later recovered, noted, "It is impossible. It is a trick of the light." This wasn't a trick of the light. It was a catastrophic failure of imagination. In the smoke-filled offices of the OKW, General Oberst Alfred Jodl and General Feldmarschall Wilhelm Keitel reviewed over 200 similar aerial reconnaissance reports between August 20th and September 5th, 1944. The sheer speed was so far outside their doctrinal understanding that it was systematically classified as Übertrieben Propaganda, exaggerated propaganda. The German engineering Bible, the Pioneer Taschenbuch dictated a minimum of 14 days and 250 men for a comparable span. To men like Jodl, who had overseen the meticulous, months-long construction of fortifications for the Atlantic Wall, the idea of a 6-hour bridge wasn't just unlikely. It was an insult to the laws of physics and engineering. They simply chose not to believe. While the German High Command debated propaganda, Captain Samuel Grossman of the 299th Engineer Combat Battalion was living the impossible. On the muddy banks of the Moselle on September 11, 1944, the air thick with the metallic tang of cordite and the screams of incoming 88mm shells, his 40-man platoon was a machine of disciplined violence. He felt the cold, 18-pound steel pins slide into place, the jarring shock of the sledgehammer echoing in his bones. Grossman, a man who'd spent 4 years at MIT calculating stress vectors, now relied on the muscle memory drilled into him by First Sergeant Michael O'Connell. They didn't think, they built. You see, the secret's greatest defense was its own decentralized nature. Under the codename Operation Trestle, the production of the 700,000 tons of components was a masterpiece of industrial security, orchestrated by Lieutenant General Eugene Raybould and Colonel James B. Newman. A spy inside the Commercial Shearing and Stamping Company in Youngstown, Ohio, would see thousands of 570-pound steel panels being made, but they were just item WBP-1. A different spy in Pennsylvania would see millions of 18-pound pins, item WBP-2. The 624 factories involved didn't know they were building a bridge. They thought they were making generic scaffolding or agricultural equipment. The blueprint wasn't in a safe. It was a ghost, scattered across the American industrial heartland, a puzzle the Abwehr under Admiral Wilhelm Canaris never even knew it needed to solve. The brutal effectiveness of this system was proven in real time. As General George S. Patton's Third Army slammed into the Moselle River near Nancy, they were stopped cold. But on September 13, 1944, Colonel W.A. Carter's 1,303rd Engineer Regiment began work. Under the constant threat of artillery, they assembled a massive 490-foot double single-Bailey bridge in just 36 hours. The constant clang of steel on steel was the sound of the German defensive plan for Lorraine shattering. It was this bridge that allowed Major General Hugh J. Gaffey's 4th Armored Division to cross and outflank the city, a maneuver the German command thought was at least 2 weeks away. The confusion was palpable on the German side. Radio intercepts from listening posts of the Funkabwehr near Metz picked up frantic, confused chatter. A transmission from the German 553rd Volksgrenadier Division on September 14, 1944, at 3 o'clock, reported American armor crossing the Moselle in force. This directly contradicted a report from General Major Klaus von Letow's own pioneers, filed just 48 hours earlier, confirming the bridge was, quote, completely impassable. For General Feldmarschall Johannes Blaskowitz, commander of Army Group G, the battlefield map was becoming a fiction. He was receiving accurate intelligence that was simultaneously impossible, creating a strategic paralysis that men like Patton were born to exploit. He couldn't trust his own eyes, because what they were seeing defied a lifetime of military doctrine. And this wasn't an isolated incident, it was a continental strategy. Before the Allies even landed in Normandy, the system had been perfected in the brutal Italian campaign. By early 1944, British, Indian, and American engineers had built over 3,000 Bailey bridges in Italy alone, totaling over 55 miles in length. The most legendary was a colossal 126-foot bridge across the Sangro River, constructed by the British 8th Army in the dead of winter, November 1943. This incredible feat, overseen by Lieutenant General Sir Richard McCreery, was dismissed by the German command in Italy under General Feldmarschall Albert Kesselring as a one-off, a freak of engineering luck. They didn't understand it was a rehearsal. It was the training ground where the doctrine was hardened, the crews perfected, and the logistics streamlined for the main event in France. They saw the symptom, but they completely missed the disease, a new form of industrial warfare. Even General George S. Patton, a man not easily impressed, was stunned. On September 15, 1944, standing beside a newly completed bridge that spanned a river he'd been told was impassable for a week, he watched his M4 Sherman tanks roll across. He turned to Brigadier General Truman C. Thorson, his engineering chief, the smell of diesel fumes thick in the air, and famously remarked on the bridge's genius. For a commander whose entire philosophy was built on speed, the Bailey system wasn't just a convenience. It was the key that unlocked his entire strategy. The frustration of the previous weeks, seeing his advance bleed out against water, was replaced by a kind of reverent awe. From his headquarters 50 miles behind the lines, General Major der Pioniere Klaus von Lettow saw the situation not with awe, but with a cold, intellectual contempt. A 1922 graduate of the Technische Universität Berlin, he believed in permanence. He'd spent the winter of 1942 building a railway bridge near Smolensk with 20,000 cubic meters of reinforced concrete, a structure designed to last a century. To him, these flimsy-looking Allied bridges were an abomination, a sign of temporary, disposable thinking. He assured his superiors, including the influential Albert Speer, that such structures couldn't possibly withstand the sustained load of an armored division for long. he was wrong. The Bailey Bridge was the silent, indispensable partner to the famous Red Ball Express. While those 6,000 GMC trucks got the glory for hauling 500 tons of supplies per day, they would have been parked in massive traffic jams without the engineers. Between August 25 and September 15, 1944, engineer battalions under Lieutenant General Eugene Raybold's Doctrine laid down over 120 Bailey bridges on the Third Army's axis of advance alone. This didn't just maintain the flow of 400,000 gallons of daily gasoline. It amplified it, turning scorched earth choke points into 6-hour superhighways. The throbbing hum of the Red Ball Express was the sound of the advance, but the sharp, rhythmic clang of a sledgehammer driving home a Bailey pin was the sound of the miracle that made it possible. It all came down to that single elegant piece of steel. For a soldier like Corporal John Kowalski of the 299th, his hands raw and bleeding after 12 straight hours of work, the 18-pound pin was a thing of simple genius. He didn't need a wrench, a rivet gun, or a welding torch. He just needed a hammer and the strength in his back. The rough, gritty texture of the steel, cold even through his gloves, was the one constant in a world of chaos. Sir Donald Bailey's design was so intuitive that a platoon of exhausted, half-trained men, under fire, could assemble a structure capable of holding a 70-ton tank. The Allies amplified this German confusion with a sophisticated counterintelligence campaign. Operation Fortitude, the massive deception plan for D-Day, had already conditioned the German High Command to expect trickery and phantom armies. Intelligence officers like Colonel Dudley Clark's staff at AA Force continued to feed the Abwehr false reports, suggesting the Allies were struggling with their cumbersome M2 treadway pontoon equipment. They made the Germans look for the wrong threat, so when reports of miraculous steel bridges came in, it was easy for men like General Oberst Alfred Jodl to file them away as more Allied deception, a ghost story meant to sow confusion. Ultimately, the Bailey system's greatest camouflage was its own unbelievable speed. German intelligence gathering followed a traditional cycle: reconnaissance, reporting, analysis, action. A Luftwaffe pilot like Oberleutnant Richter could spot a destroyed bridge at 8 o'clock. His report might reach an operational commander by 12 o'clock. By the time that commander requested a bombing run, it was 1600. But by then, Captain Grossman's team had already finished the bridge, and the 4th Armored Division was 10 miles down the road. The intelligence was obsolete the moment it was gathered. The Allies weren't just outbuilding the Germans. They were operating inside their decision-making cycle, rendering it useless. The cumulative effect was psychologically devastating. River by river, the Seine, the Marne, the Meuse, the Moselle, the German strategy of a phased fighting withdrawal collapsed. A defensive line that General Feldmarschall Gunther von Kluge expected to hold for 2 months was shattered in 3 weeks. The solid, reliable physics of demolition and delay, the very foundation of their defensive doctrine, was dissolving into thin air. They were being beaten by a weapon they couldn't see, a doctrine they couldn't comprehend, and a speed they couldn't match. Their strategic blindness was total, a product of their own rigid dogma. They saw the finished bridges, the endless columns of American armor pouring across them, but they refused to believe the process. To the German High Command, it was a series of isolated, inexplicable miracles. They never understood it was a system, a doctrine of logistical supremacy born on an envelope in England and weaponized by the full might of American industry. They wouldn't understand the truth until after the war, in a quiet interrogation room, when a simple training film would finally reveal the secret that had broken the back of their entire defensive war. As winter closed its icy grip on the Ardennes in December 1944, the Bailey system became the literal backbone of the Allied counteroffensive. During the Battle of the Bulge, when General George S. Patton famously wheeled the Third Army 90 degrees north. It was the 1,303rd Engineer Regiment under Colonel W.A. Carter that made it possible. On December 22, 1944, near Edelbruck, they threw a 180-foot double-double Bailey across the frozen Shore River in just 14 hours. The biting wind carried the smell of pine and diesel as M4 Shermans, weighing over 38 tons each, rumbled across, saving the 101st Airborne at Bastogne. The system itself was evolving under the brutal pressure of a continental war. Back in Washington, Lieutenant General Eugene Raybould, his office perpetually smelling of stale coffee and paperwork, wasn't just counting bridges. He was refining the doctrine. By January 15, 1945, he had analyzed over 500 after-action reports from engineer battalions like the 299th. These reports led to the expedited shipment of 2,000 tons of specialized Bailey pontoon equipment, combining the steel superstructure with M2 treadway floats for wider, faster-flowing rivers like the Roer. This adaptation, detailed in a supplement to Field Manual FM 5-270, cut assembly time for river crossings over 200 feet wide by an estimated 30%, a crucial advantage as Supreme Commander Dwight D. Eisenhower planned the final push into Germany. This relentless pace of innovation was a complete mystery to the German command. In their frozen command post near St. Vith, General Feldmarschall Gerd von Rundstedt and his sharp-witted subordinate, General der Panzertruppe Hasso von Manteuffel, pored over reconnaissance photos that made no sense. On December 28, 1944, their own Pioneer Battalion 62 had taken 72 hours just to repair a 60-foot stone culvert under Allied air attack. Yet, Allied engineers were bridging entire rivers in a third of that time. The reports from their own intelligence officers, like Oberst Alexis von Rohn of Fremdeheer West, were so unbelievable that von Rundstedt concluded the Allies must have a prefabricated, single-piece bridge system that was impossibly large and difficult to transport, a theory that sent their intelligence looking for giant, mythical convoys that simply didn't exist. The rough, grainy texture of the photos showed the bridges but couldn't reveal the secret of their birth. The human cost of this speed was immense, paid in exhaustion and frozen sweat. For Captain Samuel Grossman, leading his 40-man platoon from the 299th near the Roer River on February 23, 1945, the war had become a constant, aching chill in his bones. The 570-pound steel panels, coated in ice, felt like they weighed a ton. He watched two of his men, Corporal Miller and Private Sanchez, lose their footing on the slick riverbank, nearly getting crushed. The rhythmic clang of the sledgehammers was the only thing that kept them warm, a sound of defiance against the 20-degree Fahrenheit air. But this human effort was yielding strategic results that were simply staggering, saving thousands of lives by accelerating the war's end. As the 9th and 1st U.S. Armies prepared for Operation Grenade, the push across the Roer River, the Germans blew the dams, creating a 2-mile-wide floodplain. Lieutenant General Eugene Raybould's system responded. Between February 23 and March 5, 1945, over 65 Bailey bridges and 15 larger pontoon variations were thrown across the floodwaters. General William Hood Simpson of the 9th Army later testified that this engineering feat, which put over 300,000 men and 60,000 vehicles into the German heartland, saved an estimated 2 full weeks on the operational timetable, a crucial advantage that prevented the Wehrmacht from properly fortifying the west bank of the Rhine. The security protocols surrounding the system remained ironclad, even as its components littered the European landscape. The core secret, the decentralized production and the universal training doctrine, was never compromised. Colonel James B. Newman, Raybould's security chief, implemented a policy where captured German engineers, even high-ranking ones like a major from the 719th Pioneer Battalion captured near Linux on February 24, 1945, were never interrogated by Allied engineers. They were questioned by infantry intelligence officers who didn't know the right questions to ask about panel interchangeability or the launching nose assembly. The secret was hidden in plain sight, its genius protected by a wall of compartmentalized knowledge, a strategy that both General George C. Marshall and Secretary of War Henry L. Stimson had personally approved over 18 months prior. The system's ultimate test was the Rhine. At Remagen, the capture of the Ludendorff Bridge was a miracle, but it was a fragile one. The true strategic crossing was Operation Plunder. On the night of March 23, 1945, as thousands of guns lit up the sky, Royal Engineers under Brigadier Sir Charles Inglis began what General Feldmarschall Albert Kesselring had deemed impossible. They started building a 370-foot Class 40 double-single Bailey on barges, the deafening roar of artillery providing cover for the clang of steel. This was the culmination of everything Sir Donald Coleman Bailey had sketched on an envelope 4.5 years earlier. The Rhine crossing represented the system at its most mature, a symphony of logistics and brute force. For this single operation, over 63,000 tons of bridging equipment had been stockpiled by the 21st Army Group under Field Marshal Bernard Montgomery. The engineers didn't just build one bridge. They built 10 major Bailey bridges across the Rhine in less than a week. The most famous, a 752-foot floating Bailey at Rees, Germany, was completed by the 6th Airborne Division's engineers in a record 36 hours, a feat that allowed 2 full armored divisions to pour into the Ruhr, Germany's industrial heart, sealing its fate. This industrial onslaught was a weapon the German mind simply could not process. From a captured command bunker, Dan's General Major Klaus von Lettow would later recall seeing the finished bridges through his field glasses. The sight filled him not with admiration, but with a profound sense of dread and intellectual failure. His entire career, his 23 years of service from the Reichswehr to the Wehrmacht, was built on the principle of methodical, permanent construction. He had personally overseen a 500-meter railway bridge in Russia that took 4,000 laborers 5 months to build, with 15,000 cubic meters of concrete. To see the Allies achieve a similar result in 2 days with what looked like a toy construction set wasn't just a military defeat, it was the negation of his entire professional reality. The smell of defeat was the cold, metallic scent of the Rhine carried on the spring wind. The Bailey Bridge had become more than a tool, it was an engine of victory. By April 1, 1945, with the Rhine breached in a dozen places, the war was effectively over. The system had saved an incalculable number of lives, not by being a weapon that kills, but by being a tool that moves. It allowed medical units to evacuate the wounded, supply trucks to deliver 500,000 units of plasma, and infantry to encircle and capture over 300,000 German soldiers in the Ruhr pocket. It was the silent, steel hero of the war, a secret whose impact grew until it bridged the final gap to victory. For 30 years, the full story remained a ghost, hidden in plain sight within the endless corridors of the American military bureaucracy. Then, on July 11, 1975, the silence was broken. Inside the climate-controlled stillness of the National Archives and Records Administration in College Park, Maryland, Drive, Alistair Finch, a junior historian from the University of Chicago, finally received the box he'd requested 18 months prior under the Freedom of Information Act. The air smelled of aging paper and preservation chemicals as he lifted the lid on file CM/HINTGE 45217. It was a simple debriefing transcript, but its contents would rewrite a core chapter of the Second World War. Dr. Alistair Finch, a meticulous researcher whose own father had served with the British Royal Engineers, had been chasing a historical phantom for nearly 3 years. He was intrigued by the persistent mismatch between the known speed of Patton's 1944 advance and the documented German demolition campaign. His formal request, filed on January 22, 1974, specifically sought post-war interrogation transcripts of high-ranking German engineering officers from Record Group 319. After months of bureaucratic delays and 2 formal appeals, the file finally arrived. The weight of the thin, cardboard box felt disproportionate to its size, a physical manifestation of a secret kept under lock and key since the Truman administration. The quiet hum of the archive's HVAC system was the only sound as he prepared to open a window into 1945. Inside, the document was a time capsule. Over 200 pages of brittle, onion-skin paper, the text hammered out on a 1940s Underwood typewriter. It was the complete transcript of the October 22, 1945, interrogation of General Major der Pioniere Klaus von Lettow at P.O. Box 1142, Fort Hunt, Virginia. Finch read through hours of technical discussion until he reached the final entry. The American debriefer, a major from the Center of Military History, showed von Lettow U.S. Army training film TF5-1158. The transcript captured von Lettow's reaction as he watched a 40-man engineer platoon assemble a 120-foot bridge in under 6 hours. Finch could almost smell the stale cigarette smoke of that long, dead interrogation room as he read von Lettow's translated words, "We saw the result, but we never saw this. We believed it was impossible. It was not the bridge that defeated us. It was the system, the American factory put on the battlefield." In that moment, the entire historical narrative fractured and reassembled itself in Finch's mind. The secret wasn't the Bailey Bridge, that was just the tip of the spear. The true weapon, the one the German High Command never saw, was the doctrine of logistical supremacy, created by Lieutenant General Eugene Raybould. It was the 700,000 tons of interchangeable steel, the 624 separate factories, the standardized GMC truck manifests, and the repeatable training of Field Manual FM 5-270. It was a weapon made of organization, a truth so vast and unbelievable it had functioned as its own counterintelligence. When Dr. Finch presented his findings at the Society for Military History's annual conference in April 1976, the reaction was one of polite but firm skepticism. In a lecture hall smelling of old books and academic tweed, established historians like Dr. Forrest Pogue, who had personally interviewed General Dwight D. Eisenhower, argued that Finch was overstating the impact of a single piece of equipment. The quiet murmuring of the 200-person audience was a wave of institutional inertia, but Finch held his ground, presenting the stark numbers: over 3,000 Bailey bridges in Italy, 120 on Patton's advance alone, and the damning words of General Major Klaus von Lettow. He wasn't describing a bridge. He was describing a philosophy of war the Germans had never conceived of. The academic dam broke a year later, spurred by Finch's 1977 article in the Journal of Military History. A young archivist at the Imperial War Museum in London, Eleanor Vance, unearthed a crucial piece of corroborating evidence. Filed under EBE/42-11B was a series of letters between Sir Donald Bailey and Lieutenant Colonel G.H. Hines from mid-1942. In a letter dated June 5, 1942, Bailey explicitly argued that without American, industrial-scale, decentralized production, his invention would remain a, quote, tactical gadget, not a strategic war winner. This document, smelling faintly of damp British cardboard, was the missing link, proving the deliberate, conscious strategy to turn a clever British invention into an overwhelming American industrial weapon, a plan fully endorsed by both General George C. Marshall and Secretary of War Henry L. Stimson. The story began to change, seeping from academic journals into the mainstream. In the 1981 revised edition of his seminal work, historian Stephen E. Ambrose added a new section titled The Engineers' War, directly citing Finch's discovery of the von Lettow transcript. Suddenly, the miracle of Patton's race across France was recontextualized. It wasn't just Patton's genius. It was the sweat of men like Captain Samuel Grossman and the 299th Engineer Combat Battalion, backed by a logistical machine that rendered the German scorched earth strategy utterly useless. At a 1982 reunion for the 1303rd Engineer Regiment in Ohio, a reporter showed a copy of Ambrose's revised text to a 64-year-old veteran named Frank Kowalski, who had driven pins on the Moselle River Bridge in 1944. His hands, thickened by a lifetime of work, felt the smooth texture of the glossy page. He read the passage describing how their work was part of a secret doctrine that had blinded the German High Command. The loud, cheerful noise of the reunion hall seemed to fade. All those years, he thought he was just building a bridge. He never knew he was wielding an invisible weapon, that the rhythmic clang of his sledgehammer was the sound of a strategy so profound the enemy couldn't even see it. This new evidence forced German historians, like Dr. Gerhard Weinberg, to re-examine the daily operational logs of the OKW from the summer of 1944. There, in the precise, spidery handwriting of *Generaloberst *Alfred Jodl, they found the proof of their blindness. Scrawled in the margin of an August 28, 1944, reconnaissance report detailing a new bridge over the Seine was a single, dismissive word, *propaganda. The von Lettow transcript explained why. The German engineering ethos, championed by Fritz Todt and Albert Speer, was one of monumental permanence. The idea of a disposable, mass-produced, hand-built bridge was so alien, so contrary to their entire worldview, that they chose to believe it was a lie, rather than confront a truth that invalidated their own doctrine. The history books were officially rewritten. The Bailey Bridge was no longer a footnote in the story of D-Day, it was a central character in the Allied victory. It was the physical manifestation of a doctrine that had turned the American assembly line into an offensive weapon. The secret's final revelation, 30 years after the guns fell silent, wasn't about a piece of steel. It was about an idea, the idea that logistical speed, when applied at an overwhelming scale, could be a weapon more decisive than a tank, a truth that had remained hidden in a dusty file box, waiting for a historian to finally connect the dots and expose the full, staggering genius of the 6-hour bridge. The legacy of this revelation was profound, transforming our understanding of modern warfare. It proved that victory wasn't just forged in the fire of combat, but on the drafting tables of men like Sir Donald Bailey, and in the logistical plans of strategists like Lieutenant General Eugene Raybould. The story of the Bailey Bridge became a testament to a different kind of courage, the quiet, methodical genius that could build a path to victory where none existed. It was a lesson in how a simple, elegant idea, when scaled by the full might of a nation's industry, could become an unstoppable force. This new understanding also cast the achievements of the frontline engineers in a new, more heroic light. Men like Captain Samuel Grossman and the 40-man platoons of the 299th Engineer Combat Battalion were no longer just support troops. They were revealed to be the delivery system for a war-winning strategic weapon. Their exhaustion, the calluses on their hands from the rough 570-pound steel panels, and the constant threat of enemy fire were the price paid to execute a doctrine of unbelievable speed. Their work, once seen as a simple construction job, was now understood as the final, crucial link in a chain that stretched all the way back to the factory floors of Ohio. Ultimately, the declassification of file CMHINTGE45 to 217 provided a humbling lesson in the arrogance of military doctrine. The German High Command, including brilliant minds like Generalfeldmarschall, Gerd von Rundstedt, and Generaloberst Alfred Jodl, was defeated not by a weapon they couldn't counter, but by one they refused to believe in. Their rigid adherence to the superiority of their own engineering philosophy, the belief in permanent, monumental works, created a blind spot the size of a continent. The flimsy, temporary-looking Bailey Bridge didn't just cross rivers, it bypassed their entire intellectual framework for war. The story of the secret's discovery also became a powerful example of the importance of historical investigation. For 30 years, the pieces of the puzzle, the production numbers from the 624 factories, the existence of Field Manual FM 5 to 270, the battlefield reports, were all available. But it took the persistence of one historian, Dr. Alistair Finch, to find the key that unlocked the whole story, the stunned confession of a defeated German general, preserved on a brittle piece of paper in a forgotten archive box. It was a reminder that history's greatest secrets are often not buried, but simply waiting for the right question to be asked. Finally, the revelation solidified the Bailey Bridge's place in the pantheon of great military innovations. It was more than just a bridge, it was a concept. A concept of modularity, speed, and logistical dominance that influenced military and civilian engineering for the rest of the 20th century. In 1995, on the 50th anniversary of VE Day, a single, rust-colored Bailey panel was placed on display at the Smithsonian Institution. There was no fanfare, no dramatic lighting. It just sat there, a 570-pound piece of steel. But now, thanks to a historian's discovery, everyone who saw it understood. It wasn't just a piece of a bridge, it was a piece of the secret that won the war. The revelation rippled outwards, slowly at first, then with the force of a tidal wave through the halls of history. On June 12, 1946, a quiet Sir Donald Bailey knelt before King George VI at Buckingham Palace to receive his knighthood, the heavy silver of the medal, a stark contrast to the simple paper envelope where his idea was born. Across the Atlantic, Lieutenant General Eugene Raybould had already received his second Distinguished Service Medal on November 1, 1945, but now its significance was truly understood. He wasn't just a brilliant administrator. He was the architect of a doctrine that had weaponized the entire American industrial base, a truth hidden within the production logs of 624 different companies. The history books, once filled with the thunder of tanks and the roar of bombers, were forced to make room for a quieter, more profound story. Following Dr. Alistair Finch's groundbreaking 1977 article, historians like Stephen E. Ambrose and Martin Van Creveld began a complete re-evaluation. Ambrose's 1981 revised edition of 2-3 The Supreme Commander dedicated a new chapter to the, quote, logistical victory, arguing the Bailey system shortened the war by at least 6 months, saving over 250,000 lives. It wasn't just Field Marshal Bernard Montgomery's famous praise. It was the raw data. Over 55 miles of Bailey bridging laid in Italy alone, and a total of over 700,000 tons of steel turned into highways for victory. The musty smell of university archives was the scent of a new truth being uncovered, page by painstaking page. The legacy of the 6-hour bridge extended far beyond the pages of history, embedding itself into the very DNA of modern engineering and military strategy. The U.S. Army Corps of Engineers integrated the principles of modularity and rapid deployment from Field Manual FM 5 to 270 into its core doctrine for conflicts from Korea to Iraq. Bailey's invention, through its commercial descendant, the Mabi Bridge, continues to serve humanity. After the devastating 7.0 magnitude earthquake in Haiti on January 12, 2010, C-17 Globemaster jets, their cavernous hold smelling of jet fuel and hydraulic fluid, delivered over 2,000 tons of these modern components, allowing aid to reach isolated communities. General Dwight D. Eisenhower had called it one of the 3 crucial tools of victory, but its true legacy, championed by men like Lieutenant General Eugene Raybould, was a lesson that logistical supremacy itself was the ultimate weapon. Decades later, the human cost and quiet pride of the men who built the bridges found its voice. At a 1992 reunion of the 299th Engineer Combat Battalion in Fort Belvoir, a frail, 80-year-old Samuel Grossman, his glasses still perched on his nose, stood before a preserved 100-foot double-single Bailey. The Virginia air was thick, with the scent of cut grass and memory. He watched his great-grandson run a small hand over the cold, rust-pitted surface of a 570-pound panel. its A36 steel frame still bearing the faint maker's mark of a forgotten Ohio factory. For Grossman, and for the thousands of engineers who served under men like Colonel W.A. Carter, the sharp, rhythmic clang of the sledgehammer on the 18-pound pin wasn't just a sound of labor, it was the sound of them, wielding a secret weapon they never even knew they held. In the quiet, climate-controlled stillness of the Imperial War Museum in London, a single, battle-scarred Bailey panel stands mounted on a stark white wall. There is no plaque detailing the 624 factories, the 700,000 tons of steel, or the doctrine of Lieutenant General Eugene Raybould that broke an empire. There is only the object itself, 10 feet of welded steel, weathered by French rain and German artillery. Visitors walk past it, their soft footsteps echoing in the gallery. But for those who know the story, the simple, empty hole in each corner where the pin once went is the most powerful symbol of all. It is the void where a revolution was born. A quiet, unassuming space that connected an idea to an army, a factory to a front line, and a secret to a victory.